All right, so here's our third example of solving system of equations by substitution. Now, neither equation looks extremely easy to solve for x or y. Here's what I'm going to do. I'm going to solve this one right here for y, and here's why. Is because 12 and 4 are divisible by 2, and so I won't have to use a fraction. All right, so I'm going to subtract 4x on both sides, and so I have 2y equals negative 4x plus 12, and then I'll divide everything by 2, and so I have y equals negative 2x plus 6. And so this right here is going to be real easy to plug into the other equation, isn't it? Now, if you solved for x or for y from a different equation, you'll still get the same answer. There are a bunch of different ways to solve this. Just as long as you got the right answer, you're in business, okay? So here's what we're going to do. We know that y equals all that's circled, okay? And I solved this bottom equation, didn't I? So I can't go and plug that back into the bottom equation. Which equation do I need to plug it into? The top one. So I'm going to put negative 2x plus 6 in place of what? Y. And so I've got 3x minus 5, but instead of writing the y, I'm going to write what y equals. It equals this right here. Negative 2x plus 6 equals negative 4. So what I did was I substituted negative 2x plus 6 in for y in the top equation, didn't I? And now all I have to do on that top equation is solve for what variable? X. Yeah, now all there are x's, and so I can solve for them, right? So I'm going to distribute my negative 5 here and here, and I have 3x plus 10x minus 30 equals negative 4. Okay? Then I'll combine like terms. 3x plus 10x is 13x. And I'm going to add 30 to both sides. 30 plus negative 4 equals 29. Is that right? No, it equals 26. That was bad math in my head there. So I've got equals 26. And then I'll divide by 13 on both sides. And so x equals 2. So now I know x equals 2, and I want to solve for y. Which equation can I plug it into? Either one, yeah. It doesn't matter which one you plug it in. You just got to plug it for x, right, Hayden? Okay. So I'm going to plug it in the bottom equation for no particular reason. So I've got 4 times what x is. What's x? 2, because we know that from right here. Plus 2 times y equals 12. All right. 4 times 2 is 8, isn't it? So I'm going to subtract 8 from both sides. And I have 2y equals 4. So then I'll divide by 2 on both sides. So what does y equal? 2. And so I know that x equals 2, and I know that y equals 2. And if I plug them in, it'll verify that that's correct. So my answer is the point 2, 2. And so what I'm saying is if I were to graph 2, 2, that's where the two lines would what? Intersect. Very good. And so the way you can write your answer maybe on the test is you can say x equals 2 and y equals 2, like that right there.